everyone, welcome back to another video of mine, where today we're going to be solving Leetcode 53 titled Maximum Subarray. So the problem statement says that we're given an integer array nums, and we simply want to find the subarray with the largest sum and return that specific sum. We don't actually have to return the contiguous subarray itself, but solely the sum that it actually has within our array. Okay, and like I said, the subarray is defined to be contiguous, which is very important in this problem. So our example 1, we have a nums array of -2, 1, -3, 4, -1, 2, 1, -5, and 4. And our output would be 6 because that is the largest sum that any subarray within this input actually has, and which in this case is going to be 4, -1, 2, and 1, as denoted by these specific indices that I'm currently highlighting with my cursor. Okay. So example 2, we have a nums of length 1, and this array simply contains one element, of course, with, well, the value 1, and so the subarray would be 1 that has the largest sum, okay, the only element in the array itself. Now, in our example 3, we have a nums array of 5, 4, -1, 7, 8, and our output is 23 because the subarray 5, 4, -1, 7, 8 itself has a largest sum of 23, and the subarray can be the input array itself as a whole. That is still a valid subarray. Okay, so before we actually start trying to solve this problem, what I will tell you guys is the count or the sum that we're actually going to return after scanning through the array, it's always going to be non-negative, because even if every single element in our nums input array is negative, we can always have a subarray that is empty. That's always applicable regardless of what the input is, and an empty subarray will always have a sum of 0. So no matter what input we get, as long as it is actually valid, we will always be able to we'll always be able to output a non-negative total maximum sum. Okay, because we can always have a possible subarray that is empty, even if every single element in our input is negative. Okay, and of course, like we know, an empty subarray, of course, does have a maximum sum of 0. So I will give you guys a few seconds to actually try to think of a solution yourself, and if you guys can't think of it, that's completely fine. I will tell you the optimal solution of how I would solve this problem in a few seconds. Okay, so if you guys didn't get this problem, that's completely fine. I will tell you guys how I would solve this. And the way I would solve this is actually to use Kadane's algorithm. Okay, Kadane's algorithm is actually specifically designed for this type of problem of returning the maximum sum of a subarray in an input array. And the way we would do that is actually first to initialize our first, which is going to be the nums at the 0th index, or the 0th value in our nums array. And then we'll set a count equal to 0. And the count variable is actually going to be the sum, or the maximum sum, that we're actually going to return after we scan through the array and update this variable. And we'll do this like so. We'll say for I in the nums array, and now using a logic that I explained before, if our count ever goes less than 0, we can simply reset it back to 0. And then, while it's not actually less than 0, I can simply add I, okay, the iterator that we're actually using to go through the iterable nums. Okay, I can actually add that to my count variable, and now I can set my first variable equal to the maximum value of my first itself and my count variable, which stores every single possible sum that I can actually have that's non-negative within my input array, with the first actually storing the maximum value of that count. Okay, and now after this, I simply have to return my first, which stores the maximum sum, as denoted by the maximum value of the first and count. Okay, and the logic here on lines 10 and 11 says if the count variable, or the sum that we're currently looking at, ever goes below 0 or ever becomes non-positive or non-zero, we can simply reset it back to 0, because we always know that the smallest sum possible that we can return is 0. And so if it ever goes below 0, we can reset it back to 0 as our minimal sum, even if every single other element is going to be negative. And we can keep doing this and keep resetting it back to 0 if we don't actually find any positive variables, and keep adding our iterator to our count variable that scans through the array if our count doesn't actually go less than 0. We can simply set our first variable, as denoted here, first initialized to the first index, or the 0th index, sorry, the max value of course, itself to be a sustainable operand type, and the count variable that stores every single possible valid sum in our subarray, okay, or our input array. And then we simply have to return that first maximum sum. And if we were to run this, we would see that it is actually accepted, and we can actually go ahead and submit this, and we will see that it does actually indeed pass all test cases, and it is essentially the most efficient solution, both memory and runtime complexity wise. And if you guys are wondering, if you guys are familiar with if you guys are familiar with time and space complexity, the Kadane's algorithm is actually O of n time complexity, and the reason is we're actually just scaling through the input array once to keep updating our variables. So if you guys learned something new and enjoyed this video, please consider subscribing to my channel and liking this video. It really means a lot to me, and I hope you guys enjoyed. Thank you so much for watching, and I will see you in the next one. Bye-bye.